Hello guys, my name is Miguel J.S. Regala, BSCE 3D, subject, Dynamics of Rigid Bodies. We are going to talk about rotational motion. Sample problem. The pinion A of the hoist motor drives gear B, which is attached to the hoisting drum, as you can see in the figure. The load L is lifted from its rest position and acquires an upward velocity of 3 feet per second in a vertical rise of 4 feet with constant acceleration. As the load passes this position, calculate A. The acceleration of point C on the cable in contact with the drum. B. And the angular velocity and angular acceleration of the pinion A. If there no slipping will happen on the drum, the vertical velocity and the acceleration of load L are the same with the tangential velocity V and acceleration tangential AT of point C. A. The acceleration of point C on the cable in contact with the drum. So we are going to solve the normal and tangential components of acceleration of point C. So here A. Tangential acceleration is equals to V squared over 2S. S is given on the figure, which is the position, which is 4. So substituting the value, A tangential is equals to 3 is the velocity squared over 2, and then position is 4. So here, so equals to A tangential is equal to 1.125 feet per second squared. Normal acceleration, so AN is equals to V squared over R. In this, the radius given is in inch, so we are going to convert it to feet. So substituting the values, AN is equals to B is 3 squared over R. So convert na natin yung inch natin na 12 sa feet. So 2. So equals to normal acceleration is equals to 4.5 feet per second squared. So we are looking for acceleration on point C. So we are going to use the square root of A tangential squared plus A normal, or which is normal acceleration squared. So acceleration at point C is equals to square root of AT squared plus AN squared. So substituting the value, AT is 1.125 squared plus 4.5 squared. AC is equals to 4.64 feet per second squared. So this is the answer for letter A. So for letter B, the angular velocity and the angular acceleration of pinion A. So the angular motion of gear A is determined from the angular motion of gear B by the velocity and the tangential acceleration of common point of contact, while angular motion of gear B is determined on the motion of point C, which is attached on the drum. Before we solve the angular motion of pinion A, we are going to solve the angular motion of pinion B, or which is the point B. So angular velocity B So, angular B is equals to B over R, which is yung velocity natin is given, substituting the values, 3 over 2, which is yung radius natin is kanina is inches, now we're going to use feet. So, our angular velocity is equals to 1.5 rad per second. So, angular acceleration V is equals to A tangential is over R, which is equals to, substituting the values, yung A tangential natin is equals to 1.125 over radius natin is 2. Ang acceleration natin is equals to, angular acceleration equals to 0.562 rad per second. That's not the final answer, because the one we are looking for is the angular motion of point A. So since point A and point B have the same contact, which the angular motion of point A we can get from solving velocity 1 and tangential acceleration 1 is the common velocity and common tangential acceleration of the two. So that we have velocity 1 is equals to RA, angular velocity of A is equals to RB, angular velocity B. Then, tangential acceleration 1 is equals to RA, angular acceleration A is equals to RB, angular acceleration B. So to get the angular velocity of A, we are going to use this. So angular A, the velocity A is equals to manipulation of formula. So then we can get the RB over RA multiply sa angular velocity of B. So substituting the values equals to RB 1.5 over 0.5. So angular velocity of B is 1.5. So the angular velocity of A is equals to 4.5 rad per second. So angular acceleration is equals to manipulation of formula again. RB is over RA multiply sa angular acceleration, substituting the values, 1.5 over 0.5 multiply sa 0.562. The angular acceleration of A is equals to 1.688 rad per second. Then ito ay clockwise. Ito din clockwise. And this is the final answer for letter B. Thank you for watching.